Hello, health science classes. Mrs. Combs here. Um, this is our asynchronous lecture for Friday, April 30th. So welcome. What is on our agenda for today is we're going to go over our reminders, then we're going to talk about the anatomy and physiology of the ear, and then we'll talk about what we're planning on for next week. So just reminders, please submit any and all late work, check your PowerSchool, check your Wake County emails. If you have completed a test or a quiz and you notice that I have not put it into PowerSchool yet, just shoot me an email and let me know that you've completed it, and then I'll update that. And just remember your honors projects are due on the 17th if you're in the honors section of the course. So today we will be talking about the anatomy and physiology of the ear. Please continue to work on your note guides. The part of the note guide that we will be working on today, we've already completed the eye. We will be down here in the ear section. We will be able to fill out all of these structures by the time we're through today. That's where we label them down there. We will be able to talk about the functions of the ear. And then we will be able to list the steps in the auditory pathway of the ear by the time we're done today. So let's get started. First off, when we're talking about the ears, they have two main functions. Obviously, the first is so that we can hear things, right? But then the second function that we don't really think about all that often, and we're just going to briefly talk about in this class, is it helps with our vestibular system or our sense of balance as well. So we will discuss that as well, but primarily we are going to focus on our hearing, right? This second slide, which can be found on our Canvas page, has a link to a CDC website where it talks about different decibel levels and what kind of damage they can cause to our hearing after certain lengths of time. So anywho, if you feel like it, worth a look. Take home point in what you need to know, and what I would write somewhere on your note guides, write this down, is that anything at a decibel level of 80 or above has the potential to cause hearing loss. Again, anything 80 decibels or louder above can cause hearing loss. So again, if you have time and you're feeling ambitious, take a look at this website. It's pretty cool to see what the decibel levels are of different daily things that we hear. This is just an image of the structures of the ear. The ear can be divided into three different zones, so to speak. The external ear, okay, the middle ear, and then finally the inner ear. So those are three different zones of the ear. Let's talk about the external ear. So this part in our ear here, the part that we see when we see an ear, the part that we pierce when we pierce an ear, is known as the pinna or the auricle. And what it is it's just in the outer part of the nerve, cartilaginous part, that helps to collect sound waves and pass it in or funnel it in towards the ear. So something to just try at home, just even now when you're listening to me on your computer screens, if you don't have headphones in and you're just listening, try and take your ears and cup them like this. And then you're going to feel like, or you're going to hear that it sounds louder, and it is, because essentially you are making that pinna larger, allowing it to collect more sound waves and funnel them towards your ear. So yes, this is the pinna. Collecting, funneling sound waves is the function. This part of the ear here is known as our external auditory canal. Okay, external auditory canal. If you take a toothpick and clean out your ear, which we know we're not supposed to do, but we know we all do it. If you take a toothpick and clean out your ear, you are sticking that toothpick into your external auditory canal. It's what gets lined with earwax, why we feel like we need to clean out that ear, okay? its job, its function is to take those sound waves that the ear has collected and pass those sound waves on deeper into the ear, okay? Pass them this way. And essentially it wants to pass those sound waves so that they butt up against this structure here called the tympanic membrane, our eardrum, okay? So now we know we're like cleaning out our ears with the toothpick, which we're not supposed to do, and then we go a little deep and we're like, we bumped into our eardrum. Ooh, that's why we're not supposed to use the Q-tip, because you don't want to damage this eardrum. It's exactly like what it sounds. It is almost like a drum. So what happens is those sound waves that got collected and then passed through this way bang up against that tympanic membrane or that drum, and it creates vibrations. And the vibrations are the sensory information that gets passed along. So the tympanic membrane or that eardrum turns the sound wave frequencies into vibrations. It is also the separation point between the outer ear and the middle ear. Okay? Still considered part of the outer ear, but it is that separation point. Then we have the middle ear. Okay, so on one border, it is the eardrum or that tympanic membrane, okay? And then on the other border, it's the cochlea, okay? And what it is, essentially, is just like a cavity within our temporal bone. Within that cavity, there are 3 different little itty-bitty bones in there, okay? We'll talk about those in a second. So these bones, again, smallest bones of the body, very small. This is a picture of them zoomed in. So we have the malleus, the incus, and the stapes. The stapes is the smallest bone in the body, worth knowing, okay? You can see that that malleus is attached to the eardrum, okay? And then the other end of it is attached to the incus, which is then attached to the stapes, which is then attached to this structure called the oval window sitting on the cochlea. So what happens when those sound waves hit the eardrum, hit that tympanic membrane? That tympanic membrane creates vibrations. Those vibrations get passed along these bones in through this hollowed out cavity, okay? Those vibrations pass along these 3 little itty bitty bones and transfer to the cochlea, okay? Very cool. So middle ear is essentially just a cavity within that temporal bone. Okay. It actually has a connection point right here into the pharynx. Okay. Do you remember the pharynx is the throat? Yeah. So it has a connection point from that middle ear to the pharynx, known as our eustachian tubes. Eustachian tubes. And what those help to do is maintain the pressure of that middle ear. Has anybody been on an airplane before, or even just driving like on a mountainous road or a hilly road? And you know how sometimes when you change in elevation and you feel like you have to pop your ears because it just feels like too much pressure, so you do one of these pop your ears? That is essentially releasing the buildup of pressure within this cavity out of that eustachian tube into the pharynx. So that's how we control the pressure in there. Too much buildup of pressure of a cavity that lies within a bone could obviously be very painful. Okay? Interesting stuff. Science. Okay? So again, these 3 bones, smallest bones in the body, their job, their function is simply to transmit those vibrations created by the tympanic membrane onto the cochlea. Oh, yeah, those are all the middle ear structures. So now we're talking inner ear. So now we've reached the inner ear and that cochlea and these semicircular canals. Okay. Let me see. We'll go to this slide first and then we'll jump back. Okay. the round part, the part that kind of looks like Ursula's necklace, Ursula's shell, that part is the cochlea. So that is the area that collects those vibrations from those little itty bitty bones in the middle ear. And that is what passes on those vibrations, that auditory information, that auditory data, and passes it from the cochlea to the either auditory nerve, cochlear nerve, you may hear it called several things, so that our brains can process what all those vibrations mean, what we are hearing, okay? So it's a spiral-shaped organ, Ursula's shell, right? Within that cochlear duct area, there's fluid, and that, again, passes on the vibrations that it received so that then it can be picked up by that auditory or cochlear nerve and sent to the brain. Does anybody remember what part of our brain processes our auditory information or our hearing? Yeah, the temporal lobe. Oh yeah, the temporal lobe. You're right. Wonderful. Okay, great. So there's like little hairs here that are within that cochlear duct as well. So the cochlear duct contains fluid and it contains these little tiny hairs. And again, just transmitting those vibrations along. All right? And that is the pathway of hearing. Okay? The pathway of hearing ends in that cochlea. But then we have all of these other structures up in here. Let me flip back to the other page. We have all of these other structures here that look like little tubes, okay? These things are collectively known as the semicircular canals. The semicircular canals are involved in helping us with our balance and our equilibrium, all right? We don't have to get into a whole lot of detail about that in this class, but what we need to know is that within these canals, there are tiny little hair-like projections, and there's fluid. You can see the canals go in different directions, like that, like this. And what those do is when we turn our heads in any direction, right, the fluid that is within these canals rushes in one direction or another based upon what way we've turned our head, and it creates sensory information by moving those tiny little hairs within those semicircular canals, and that sensory information gets passed by way of the vestibular nerve to the area of our brain that processes our coordination. Does anybody know what lobe, what part of the brain processes coordination of movement? Yeah, the cerebellum in the back. Yeah. So the cool thing about this is that say you close your eyes and you start falling towards your right, like you know that. Your body knows it without that visual input. Your body knows it in part due to these semicircular canals communicating sensory information of head position to your cerebellum. Neat science, right? So what I want you to note about this picture, and what is a tricky concept, I think. So we had the cochlea, which is part of the inner ear, which we said is more involved in the hearing. And then we have the semicircular canals in the inner ear, which is involved mostly with vestibular balance stuff. So it's actually two nerves that form together to make one. So the cochlear nerve is attached to the cochlea, makes sense. The vestibular nerve is attached to the semicircular canals, okay, because it processes vestibular info. The vestibular nerve and the cochlear nerve, out of the view of this picture, actually merge together into one before they branch off again. But the merging point, these nerves are collectively known as the vestibulocochlear nerve. Vestibulocochlear nerve. Let me check what number that is. That is cranial nerve number 8. okay? But you'll hear us talk